Okay, welcome once again, guys, to our class today. It's another week, third week already, and I hope so far you have learned about how to make use of R and R Studio, of course, R Markdown or R Notebook through projects. And I haven't checked your work yet, but I'll check it this week so that you will have the results already for this week. Okay, now we go to, as I said, guys, we're not going to look at the rest of the data structures. If you have any questions about it, please feel free to PM me. Okay, I'll try to see if I'll try to find the recording of that portion. I haven't seen it, but once I find that, guys, I'm going to post it also in our Canvas so that if you have some doubts about that specific part of the topic, then you may be guided. Kasi importante yung portion na yan kasi ando dun yung matrices, no? Eh, gagamit tayong matrices dito sa multiple linear regression. Okay, so may I invite you to please open the RMD file that we're going to use today. Okay, so we're going to start now with the topic on multiple linear regression. So I'm sure in your previous subjects, in statistics subjects or management science or DSI Lytic, I'm sure you have already discussed this. Albeit maybe you used Excel or maybe in your FINTSAR. No? Did you study regression in FINTSAR, guys? I think you answered that question already. But did you kindly refresh my memory, please? Sa FINTSAR, di ba? Did you study regression, multiple regression? So I checked the syllabus of the FINTSAR last term. Parang may multiple regression table. Okay. Now, if I'm not mistaken, you used, anong ginamit yung Stata or Excel? Anyone? Yes? Those of you who took FINTSAR last term, one term ago pa lang, last term pa lang yun, di ba? So what did you use? Excel. Iba Excel, iba Jamovi. Okay, that's good. All right. For this subject, guys, we're going to, of course, reinforce our learning in R. Okay, so let's have a quick review of what we have learned so far in okay. Right, very simply, guys, I'm sure you have learned about the definition of multiple linear regression, aka MLR. Okay, so it's a statistical technique. Just going through through what I wrote here. Okay, it's a statistical technique. Notice, guys, it's not a simple linear regression. We're not going to look at that anymore because I'm sure you have had that lesson already before. So we will just focus on the nuances of MLR, multiple linear regression. The only difference between a simple linear regression with that of a multiple linear regression is the presence of several regressors, okay, several explanatory variables or several independent variables or IVs that we use in order to predict the outcome of a response variable or dependent variable. So, dapat, guys, yung dependent variable natin continuous, no? Dapat quantitative. Kasi if it takes on another form, okay, kunyari character siya, character variable yung dependent variable natin, hindi na pwedeng multiple linear regression. No? Kung if the dependent variable is binary, 0 and 1 lang, or true or false, then hindi na rin pwedeng multiple linear regression. No? Ang gagamitin natin doon, binary logistic regression. Okay, so what's the goal of the MLR? Well, it's to explain the relationship between your explanatory variable and your response variable. We'd like to see if there's a relationship between your several explanatory variables and your response variable. And the method that's used here is your OLS. No? If you recall your ordinary least squares, what we're trying to define is a regression line where the distance squared of your model from the actual data points is minimized. No? So kaya nga least, L-E-A-S-T, yung pinakamaliit. No? Pag simple regression, madali lang kasi line lang yun. Pero pag multiple regression, it's already a plane, P-L-A-N-E. So medyo mahirap makita visually yung plane na yun. So that's why we will have to rely on other measures in order to see if indeed this is the optimal solution, pinaka-best na regression equation. Okay, I gave here some, this is a, pwede kong lagay dito na lang, no? Para pag ilan natin ito, gamitin ko yung, okay. Lagi yung guys, ipapractice na, no? Practice nyo yung pag-write ng pag-access ng isang URL for a ano, so for a markdown notebook or HTML document. Okay, always make it a practice already. Dito, ipapakita ko sa inyo na hindi ko ginawa, no? So I will leave that to you guys. Kasi when you need this, it's good to need this so that when you review guys, makikita nyo yung document mismo at saka yung outputs. Okay? So let's try to open this. Let's open this. Sabi medyo mabagal yung ito. Example site lang to guys. Of course, marami pang iba. Okay, so ito guys, you know this is LaTeX, di ba? We already discussed this before. This is how to write equations. Okay, you will be needing this guys because your next project now is multiple linear regression and you need to write the equation. Okay, so we discussed this last time. So for example, yung summation, paano ba sinusulat yan? Okay, this is akin to a variance, a linear model guys. Ito, di ba? Y regress on X, X1, X2 plus the error term. Okay, so this is just a simple R markdown for scientist reference. Okay, so this is an example. What am I writing here? Okay, so lalabas dito yan, no? Okay, anyway, so what did I write here, guys? I wrote here, this is the equation of the multiple linear regression line. Multiple linear regression. Ito guys yung formula natin. So we should be very clear about this guys as early as now. Dapat alam natin to by heart. No? That here is your dependent variable y and this should be a continuous variable. Dapat numeric siya. Hindi pa pwedeng character. No? Otherwise guys, pag character na yan, multinomial regression na tayo. No? Hindi multiple, multinomial. As the name suggests, many names. Kasi nominal yung dependent variable natin. But we're not going to discuss that. So we know that your response variable or your outcome variable y is here explained by several explanatory variables here, n explanatory variables. No? Okay, so x sub 1, x sub 2, up to x sub n. These are your explanatory variables, and of course, dun sa dulo is your residual or error term. Okay, I, where your I is equal to the nth observation. Okay, y sub I is your dependent or explanatory response variable. X sub I is your explanatory variable. B sub O is your, this one, is your intercept. And B sub N, beta sub N is the slope coefficient for each explanatory variable. And error, epsilon, is the model's error term, also known as the residuals. And so you notice that this is a centered printout of this equation. Simula sa begin, simula sa end, tapos naka-align. At align siya para they fall in one common margin. Yeah, nicely written. Okay. All right. So there are several assumptions to regression. Now, this is very important, guys, kasi when the assumptions of multiple linear regression is violated, then that might lead to questionable outputs. Baka yung output natin hindi na reliable, no? Especially pag ginagamit natin for using the output in order to predict. For example, in a business, gagamit tayo ng multiple linear regression in order to predict demand. Tapos may yung ano pala natin, yung data natin, medyo it does not fit an MLR model. And then we make decisions based on the output, not realizing that we were violating certain important assumptions of classical linear regression model. In that case, guys, baka magkaroon ng maling mga malabong mga predictions. Okay? All the more, guys, kunyari, towards the end, magkakaroon tayo ng example ng machine learning, di ba? And machine learning is oftentimes used sa medical field. If you're taking a look at the efficacy of a particular drug, tapos kung mali-mali naman pala yung pag-ano natin ng model, then that can lead to lives being lost, di ba? So imagine the implication if we are wrong about the application of linear regression. Okay, so we'll take a look at several assumptions. Okay, we will just look at this briefly, and then I will leave you guys to do further research about this, because it's very important that we understand what these assumptions are. Number one, linearity of the data. Okay, so what do we mean by linearity of the data? Okay, when we say linearity of the data, we're referring to the relationship between your independent variable and your dependent variable. Okay, so ano ibig sabihin nun? If your dependent variable can best be described by x, kunyari yung independent variable y. Tapos, if it can be best described by x squared rather than just x, then that means na hindi linear relationship ng ano natin, ng relationship ng y at saka ng x natin. Yung y is the dependent variable and x is the independent variable. Okay, so if you plot, for example, x and y, and makikita natin na linear naman yung relationship nila, then it's okay to use a multiple linear regression. But if we see that the relationship between your x and your y is not linear, kunyari curve, parabolic, no? Okay, o kaya polynomial, may mga curves na ano. And then, so that means, guys, na mukhang hindi maganda yung paggamit ng multiple linear regression. The assumption always is dapat linearity ng data. Dapat yung relationship ni x at saka ni y, dapat they should be linear, no? So it says here, the relationship between the predictors or our explanatory variables x1 and xn and the outcome variable is assumed to be linear. Okay, as I mentioned here, one way to check it is by producing scatter plots, which we're going to learn. So ipa-plot natin si x at saka si y. Tingnan natin kung yung relationship ba nila linear. Otherwise, kasi kung hindi linear, then maybe that independent variable is not a good explanatory variable. It's not a good predictor of your outcome variable. Okay, next. Number two, hindi lang linearity of the data, linearity of the parameters. Okay, what do you mean by this? Assumption to requires that the specified model to be linear in the parameters. Ano yung mga parameters natin? What are the parameters? Yung beta null, yung beta 1, beta 2, beta 3, beta 4. Di ba yun yung slope ng parameters natin? So dapat linear sila. Linear sila. Hindi sila dapat quadratic. Okay, let me show you let me specify this by an example. Okay, so take a look at this. In order for OLS to work, the specified model has to be linear in parameters. And when I say parameters, guys, yung mga slopes natin, yung beta, yung mga betas natin. Okay? So, if it is true, if the true relationship between your x and your y is nonlinear, then it is not possible to estimate the coefficient beta in any meaningful way. Okay, let's take a look at this. No? Tingnan natin dito. Okay, take a look at this, guys. Y sub I is equal to beta null plus beta 1 squared times x1 plus beta 2 times x2, etc. Now, if you take a look at this, the parameter beta 1 is not linear. Or this can be square root. Okay? Or this can be log of b1. Okay? Now, pag nakaano to, pag hindi siya linear lang na beta null or beta 1 or beta 2 or beta 3, pag non-linear siya like beta 1 squared or square root of beta 1 or log of beta 1 or 1 over beta 1, then it ceases to be linear, then, okay, wala na, mahihirapan na tayong i-estimate yung beta 1 squared na yan. Okay, assumption 2, which we mentioned, linearity of the parameters, requires the model to be linear in parameters. No? OLS will not be able to estimate this equation in any meaningful way. Hindi kakayanin, guys, ng OLS, ordinary least squares, yung method na ginagamit natin, to estimate kapag hindi, if the parameters are not linear. Okay? Okay, take note that I said the parameters, yung mga estimates natin. Kasi yung mga x mismo, guys, pwedeng nakalog yan. Pwedeng naka-square it doesn't matter. For as long as the parameters themselves are linear. Okay? Assumption 2 does not require the model to be linear in variables. Okay, what do I mean by that? Okay, dito, here. Tingnan nyo, guys, dito. Y sub I is equal to x1 squared. Diba? Or square root of x1 or log x1. No problem, pwede yun. Okay, I hope that's clear, guys. No? Na pwedeng yung x's, pwede siyang naka-log, log of x1, pwede siyang naka-e, e to the x1, pwede siyang naka-square root, cube root, etc. Or 1 over x1, pwede yun. Pero yung mga parameters, yung beta 1, beta 2, hindi siya pwedeng naka-square root or non-linear. Okay? Okay. Clear, guys, yung mga assumptions natin, yung linearity of the data, yung relationship ng x and y, and linearity of the parameters. Okay. Were this discussed carefully sa sa FINTSAR nyo or sa ibang hindi yata hindi siya masyado yata tinitingnan talaga yung strictly yung mga parameters. No? For us, guys, this is very, very important. No? Kung hindi masyadong diniscuss nyo to dati, dito, gagawin pa natin ang equation yan. No? Okay? Kailangan natin yung equation tapos yung matrix pa. No? Kaya nga, guys, may I really request you to go through the data structures, yung mga matrix doon. Kasi importante sa atin yun. No? Importante sa atin yung equation ng matrix ng mga assumptions. Okay? So this is what separates a person who really understands MLR and a person who just on the surface knows MLR. Okay, any questions so far about linearity of the data and linearity of parameters? Clear ba so far, guys? And in chat, please. Clear. Feedback, please. I'll appreciate any feedback from you, guys. Okay, sana 100% guys ang mag-feedback para alam ko na na almost all of the class understands. And if you have any questions, please feel free to ask a question. Okay, 20 students pa ang hindi nag-respond, guys. Wala po tayo sa lahat. Appreciate any response from anyone, guys. Very good. A few more guys. Ano maka 20, ano tayo, 20 plus. So 15 pa lang yung nagre-respond. %50 pa lang tayo. Yan, thank you. So let's just wait for a few more seconds for others to respond na nakuha nila yung first two assumptions. No? Linearity of the data. That's where we look at the relationship between your independent and your dependent variable and the linearity of the parameters. I hope that's clear, guys. Thank you so much. Although hindi pa lahat ng respond lahat. No? Sana next time, guys, pag mag-request ako ng ganyan response, I hope everybody does. No? Okay. Thank you for those who responded. Okay, let's now go to okay. All right. Number 3, guys. Homogeneity of residuals variance. Okay. When we come up with a model, guys, an equation, a mathematical equation where we describe the relationship between your dependent variable y, okay, and your independent variable x. So, kunyari ito, no? Chances are, guys, the model value, okay, kasi may mga values ng x1, x2, x3, hanggang xn. May mga values yan, di ba? For a particular response, for a particular observation, meron kang value ni y, meron ka rin value ni x1 hanggang xn. So if we compute for the value of y using the model, using the equation, then we will get a predicted value. Pag kinumpare natin yung predicted value na yun dun sa actual value, the difference is what we call residual. Okay? It's called residual. Now, pag plinat natin lahat ng mga residuals, dapat, guys, dapat walang pattern yun. Okay? I'll illustrate that next time. No? Dapat walang pattern yung mga residuals pag plinat natin siya. If we plot it and if we see that it has a pattern, kunyari, may trend siya, tumataas siya. Oops, may problem tayo doon. Kasi guys, hindi what we call, hindi constant yung variance natin pag ganun. Pag tumataas, guys, yung mga residuals natin, may pattern siya na over the values of x, it goes up. Then we have a problem kasi that's what we call heteroskedastic na residuals. And we don't want that. No? Kasi kapag heteroskedastic yung residuals, ibig sabihin hindi siya constant. No? Either tumataas siya or nagfa-fan out siya. Ibig sabihin, it keeps on increasing over the values of your independent variables. Imagine a fan, guys. So parang habang lumalakad siya over x, over the independent variables. So that's what we call a heteroskedastic variance. And we don't want that. No? Ang assumption, guys, ng multiple linear regression is that homogeneous yung variance. Homoskedastic siya, not homogeneity of residual variance or homoskedastic siya. Ibig sabihin, constant yung variance. Walang fanning out, walang trend, upward trend, or walang downward trend. Okay? Makikita natin yan if you look at it across the x values. Okay? Constant lang siya. No? Constant lang siya. The spread is constant. Fairly constant at each point of the predictable variables. Okay? Next, guys, we will show this, guys, as an equation next time. Number 4, guys, the explanatory variables are not collinear. Okay, this is very important. So if you have, for example, 5 independent variables, tapos yung dalawang variables doon are related to each other. Kunyari, si y1 is simply equal to 2 times y2. In other words, guys, related x1 is equal to twice of x2. In other words, guys, si x1 is just a function of x2. Okay? So we will have a problem there kung ganun yung mga ano natin, kung ganun yung mga variables natin, yung mga explanatory variables. Okay, take note na. What I'm saying is that yung explanatory variables natin, yung x1 hanggang xn. Dapat hindi sila collinear. Dapat yung correlationship nila mababa. Now, I'm not talking about y, yung dependent variable, and x, the independent variable. On the contrary, gusto natin na si x at saka si y, very high yung correlation. Okay? Kasi kung mababa yung, kunyari, zero yung correlation ni y at saka ni x, then that means, guys, hindi natin magagamit si x as a predictor of y. Kasi wala silang correlation. Diba? Now, if they have a high correlation, then that means then x is a good candidate to predict or to explain our outcome variable, our response variable y. Okay? So, I hope that's clear na. X and y, gusto natin strong yung correlationship nila. However, y between y's, y1 and y2, y1 and y3, etc., we don't want them to have a strong correlationship. Kasi mag-aagawan lang sila in trying to explain x. No? So, here I said that it's essentially the predictors are not too highly correlated with one another. A multicollinearity will exist when two or more of the explanatory variables are highly correlated, and this will be a problem. Bakit? Mahihirapan tayong masabi kung ano yung how is variable x1 explaining x2 kung highly correlated sila. Mahirap disentangle. Kasi magkakaroon sila ng shared variance. Ilang proportion ngayon ang ina-explain ni x1 on y? Ilang proportion ang ina-explain ni x2 on y? Diba? So that's the problem there. No? It will be hard to disentangle no? yung explanatory power of each of those variables. Okay? Also, kapag kapag highly correlated, it also suggests that the two variables may actually represent the same underlying factor. So, ibig sabihin, baka pareho lang sila. Maybe it's best to just use one. Okay? Just one of the variables kasi pareho naman ang ina-explain nila about x, about y, I mean, about the independent variable. Okay? So, those two guys, dapat yung residual variances natin, dapat homoscedastic. No? Pag heteroscedastic yan, may pattern, tumataas guys, o kaya bumababa, o kaya nagpa-fan out. Imagine a fan guys. Di ba pag binuksan yung fan, yung abaniko yung ginagamit ng mga ladies. No? Pag ginamit nyo yung guys, pag binuksan nyo, di ba? Ganun yung shape niya. So hindi yung constant variance, heteroscedastic yun. Okay? That's the fourth. The fifth guys is, dapat yung mga residuals guys, dapat hindi sila dependent. No? Dapat independent sila. Okay, I'll explain this again as we go along. So, a broad overview of the assumptions of a classical linear regression. And sixthly, dapat yung residuals normally distributed. Okay, so let's go through those six assumptions again. Yung iba marami, no? Dinadagdagan pa nila. But for us, these are the most important ones. Number one, dapat yung relationship ng dependent natin at independent, it's better if they're linear relationship. Okay. If it's a parabola or if it's any other type of relationship na non-linear, okay, that's not a good, it will not give us a good model. Number two, linearity of the parameters, yung mga parameters natin, yung slopes natin, okay, it can only be linear. Hindi siya pwedeng naka-square root, naka-square, naka-log, hindi ito pwede. That being said, guys, pwede yung mga independent variables, pwede naka-ano siya. Take a look at this. No? Si x dito, x1, naka-square siya. Si x2, pwede rin naka-log, logarithm. Pwede yun. No problem about that. Ang problema kung yung mga parameters natin ang non-linear. Third assumption, guys, residuals, guys. How do we compute residuals? Residuals are computed, guys, by first identifying the model. Dapat may model muna tayo. Okay, so multiple linear regression tayo. Tapos sasabihin sa atin kung ano yung mga significant predictors doon, tapos ano yung mga slopes nila. So based on that, we're going to compute y. Okay, given yung mga x natin, yung mga significant na x. Pag na-compute natin si y, we will compare that with the actual value of y. So the difference between the two, the predicted y, the model y, and the actual y is your residual. Okay? Now, pag plinat natin yung residuals, dapat yung residuals natin is walang pattern. Okay? Walang trend. Random lang siya. Hindi siya parang fun-like na over x. Pag lumalaki yung x, lumalaki yung variance niya. Eh, hindi siya tumataas, hindi siya bumababa. Dapat random lang siya. Okay? So that's the third assumption. The fourth assumption is that dapat yung explanatory variables natin, yung mga x's natin, hindi pa pwedeng related to each other sila. Kaya titingnan natin yun guys, magpa-plot tayo, magpo-4-plot tayo, and then see, oops, tingnan si x1 at saka si x2. Hala, ang correlationship nila, 0.98. So, halos perfect relationship. Magkakaproblema tayo dyan. Class, kung yun parehong gagamitin natin, as a predictor, magkakaproblema tayo dyan. One of them has to go. And there's a process for us to do that. No? Pag nagba-backward linear regression, may tatanggalin doon. No? Doon sa mga multi-collinearity. Okay? Independent, guys, independent ng residual terms, ibig sabihin, walang kinalaman yung residual ng x sub 1, 1 with x sub 2, 1. Okay, walang kinalaman ng residual ni observation 1 kay observation 2 kay observation 3. Okay, usually nangyayari yan guys, yung independence ng residual terms pag time series. Pero pag cross-sectional series guys, okay, pag cross-sectional yung natin, yung data natin, hindi masyadong problema yan. Okay? Alright, let me pause for a while. What's the difference between a time series and a cross-sectional series guys? Anong difference sila? Anyone? Na-discuss nyo ba yan sa FINTSAR, no? What's the difference between a time series, ito ko nalalagay, the difference between a cross-sectional series versus time series. A very important sa atin to, guys. Kailangan master natin. Yes, David? Yes, David, please.
I'm just gonna read out a Google search.
Yeah, sure. Go ahead.
Yeah, so
Yeah,
the difference between time series and cross-sectional data is that time series data focuses on the same variable over a period of time, while cross-sectional data focuses on several variables at the same point of time.
Thank you. That's correct, no? Okay. So cross-sectional, guys, you're taking a look at several units or individuals. No? So this is cross-sectional. Cross-sectional. Okay. Unit or individuals, several. Okay. Ano ibig sabihin nun? Kunyari, we're studying GDP, GNP. Okay. Pag cross-sectional, guys, we take a look at GNP, GDP of several countries. Several countries. Okay, kaso, yung time frame mo is only 1 point in time. Kunyari, what's GNP, GDP of Singapore, of ASEAN countries, no? Of South Asian countries, or Europe, no? And what are their GNP, GDP in 2021? Okay, so that's an example of a cross-sectional series. No? Pag time series naman guys, pag time series siya, okay, yung unit natin, okay, isa lang unit. Pero yung time frame, several. Okay, for example, let's look at the GDP of the Philippines. No? Philippines lang. 1 unit lang. Philippines, 1970, 71, 72, hanggang 2021. Okay? So what's the unit of interest? Isa lang, Philippines. Okay? Although, pwede natin tingnan yung iba't ibang variables, GNP, GDP, employment rate, inflation, okay lang yun. No? Pero isang unit lang yung interest natin sa Philippines lang. Okay? Pero it's taken across several time periods from 1970 to 2021. So that's what we call a time series. Now, when we combine the two, we will have a panel data. Any panel data? Combo ni cross-sectional and time series. Okay, so tingnan natin. Tingnan muna natin si cross-sectional. So you have several units: Singapore, Malaysia, Philippines, Thailand, Indonesia, Vietnam, etc. Lahat ng ASEAN. Ano tinitingnan natin? Yung mga variables ng GNP, GDP, etc. Pag cross-sectional lang yan, 2021 lang yan. One time frame lang. Ang gawin natin, guys, let's go back. Isama natin si 2022, 2020, 2019, 2018, 2017. Diba? So you have several individuals, several units, but now you're taking a look at it from several points in time. You now call that a panel data. Okay? So yun ang difference itong tatlong to, guys. Cross-sectional, time series, at saka yung panel data. Towards the end, guys, meron tayong analysis of panel data. So si panel data, combination niya ng combination niya ni cross-sectional at saka ni time series. Okay? Guys, paki-chat nga kung okay so far. Naintindihan yung assumptions natin kanina, anim na assumptions, kasama yung normality of our data set and also yung differences between yung cross-sectional kasi kaya ako na-discussion kasi guys dito, yung independence of the residuals. Yung independence of the residuals, guys, mas nagiging problematic yan kapag time series. Not so much kapag cross-sectional. You know why? Kasi pag cross-sectional, guys, kasi di ba independence of residual terms, ibig sabihin yung magkakalipit, related ba sila? Okay. Pag cross-sectional, guys, it doesn't matter kung bago-baguhin mo yung order. Kunyari, Singapore muna dito, number 1, Philippines number 2. Kung gagawin kong si Singapore number 17, Philippines number 5, dun sa list ng data natin, ng cross-sectional data. Then, papabago na yung katabi ni Philippines o katabi ni Singapore, mababago na yung correlation ng dalawang yun. Okay, I hope you're getting me. Kasi pag cross-sectional, guys, it doesn't matter kung paano natin i-order yung data natin. It can be alphabetical, okay, sorted from A to Z or Z to A, or it can be random. Pag binago-bago mo yung ayos yan, magbabago na yung correlationship ng magkakatabi ng data, yung residual sila. Pero ang time series, guys, hindi pa pwede. Diba? From 1970 to 2021, dapat sunod-sunod yan. May order talaga yan. There's a chronological order. Okay, and we cannot just put 2021 at the start and then 1970 sa gitna. Okay, because we will violate the structure of the data. So mas prevalent yung independence yung dependence ng residuals, yung violation niyan sa isang time series as compared to a cross-sectional. Okay? Kaya nga natin din-discuss yung cross-sectional at saka time series at saka panel data. Lastly, guys, yung residuals dapat normally distributed siya. Okay, I have here some references. I just want you to look at that. Okay, so in multiple linear regression, we're going to use several packages. Now, I'm sure you might, okay, site, paste text, kasama na rin natin dito kasama na rin si control si H. Smith, kasama na rin natin. Sino pa ba? Si paste text, si scheme RC, kasama na rin natin. Right. Kindly run that, guys. I'll give you a few minutes to run this. Tapos sa ilalim, i-access natin siya, i-library natin. When you're done, guys, chat please kung done na. Thank you for those who responded. Thank you. So kindly, guys, install the packages. As I mentioned last time, guys, from the last time we looked, more than 19,000 packages. Of course, we won't be using all of them. Siguro mga 30 to 40 packages ang pinaka-importante sa atin in this subject. And here are some examples. Site, pastex, OLSRR, gagamitin natin for forward and backward regression, stepwise regression. Stargazer for creating beautiful tables. HMIS, SchemR. Here are just examples of some packages. Once you have installed it, guys, and required it through library, paki-chat naman please para alam ko kung sino yung mga tapos na. Okay, mag-post ko muna ng recording, guys, para hindi tayo Okay, so let's run these packages and then let's see. Now, it's always helpful, guys, to at least see what a particular package can do. So, kailan natin habang nag-library pa si Stargazer at saka si HMIS. Okay, right, done. Okay na. Alam ko tapos na, guys, dito sa console kasi may greater than symbol dito. Okay, for example, si site. Site package. Okay, it's always good to go to the documentation and try to see what this package can, ano yung mga functionalities niya. Kailangan ko siya. So, if it doesn't run, guys, I want you to check individually, itong mga packages na to. Always a good practice, guys, na ayaw. So let me just wait. Pwede rin natin tingnan dito sa packages and then type site. Procedures for psychological, psychometric, and personality research. So ito, guys, ginagamit sa so may mga statistical functions to kasi ang psychology, guys, diba, may mga sa research nila dito. Okay. Anyway, guys, you can surf the net na lang. Pero I want you to look at this, at least have an idea, guys, kung ano yung mga functionalities ng package nito. Sometimes there will be functions that may conflict with each other. Kunyari, si HMIS at saka si site, may mga functionalities sila na nagko-conflict. So it's very important for you to to identify kung saan package ang galing ang gusto mong gamitin ng isang function. So let's just have an example. Okay, so there are many ways, guys, to import data. No? So first, let's take a look first on Control Alt I. Tingnan natin, guys, kung ano yung mga data that comes in R. So we can use the data function. Control Enter. Yeah, it will give us a list of several data sets that are found in R. Okay, ito tells us the package, okay, air passengers. Okay, ito yung ano yung data set niya. Sorry. This is from the datasets package, and this is the name of the data, data frame, air passengers. This is not the package. This is the data. Galing siya sa datasets na package. Okay, so ang dami, no? Ang daming datasets. Ito yung OLSRR, guys. No? Ito yung gagamitin natin. Datasets in package OLSRR. Okay, I'm not sure, guys, if this is a listing of the datasets that come with the packages that I have already installed. Okay, hindi ko pa na-check. But if that's true, guys, then may mga datasets na wala sa inyo kasi marami na akong in-install na packages which should not be, most probably should not be there in your machine. That's okay. Basta aware tayo, guys, na may mga dataset na that's already included in R, and also when you install some packages, they come with datasets which we could use. Okay, so let's go back. All right. So sabi dito, okay. Import natin, ang gagamitin natin, guys, si data frame wage. No? We're going to import data frame wage. So there's the quick way is to write your function. Pero pag hindi mo pa kabisado, guys, there's a very easy way to import your data and load it to R. So you can use here in the environment now tayo import dataset. Let's click this. And then we're going to import yung dataset na share ko sa inyo, yung wage CSV. So since it's a text, we can use the text base, or we can use text read R. Okay, let's use this yung sa read R. Kasi ito, guys, yung read R, this is a package. Ibig sabihin, dapat in-install natin itong package na to para natin magamit yung read R na package na to. Okay, so file, please look for it in where you saved it. Again, guys, sana dinagay niyo siya sa okay, sandali. Hindi ko pa pala nasa-save dito. Okay, can you do that now, guys? Ano ko lang. Control C, copy ko lang to. Tapos ilalagay ko dun sa our projects natin. Projects, and then dito sa function. Okay, so it's already here. Let me go back to R. Nasa project siya. Our projects, FINTSAR. No. Our projects, FINTSAR. Okay, wage. Open. There. Okay, so if you take a look at this, ito yung laman niya, no? Ito yung laman niya. So you notice these are the variables: education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. And if you see, guys, may double, diba? So numeric siya, character, and then double. Okay, now Below, guys, you can see here the code that was used. So ito yung ginamit na code. No? What you can do is you can copy this. Take note, no? Nag-library reader muna siya. Control C. Tapos ikakopy ko siya dito sa mamaya, import ko na muna. Pinapit ko. And then, first row as names. Okay, tama. Check nyo lang. No? Trim spaces. Open data viewer. Ito yung view. No? View. Import na natin. Okay. Tapos, nakalagay na yung code dyan, guys. Tapos, pinakita na kagad yung view. And then, what we can do is, dyan yung code niya. No? Yan. The code is there. In library are, and then this is the code. So I can copy that. And so I'll be kanina kinapit mo. Yeah. Okay. So this is the code in order to download that data. Ang ginamit kanina natin yung read R. No? Pwede naman ginamit natin yung base R. Pag base R, okay na yun. Hindi mo na kailangan i-require yung read R na package. And we're calling it wage, then read underscore CSV. And this gives us the link nasa FINTSAR wage.csv. And then ito yung automatically pinakita na niya. Okay? Alright, pause for a while. Any questions, guys? Were you able to upload to the wage dataset? Okay, chat naman please. If you're done, let's give your classmates a few minutes to download it. If you have any questions, guys, please feel free. Okay, thank you. 4. Iba? 6, 8, it's good. Let's wait for the others. Kasi importante guys, na maloadan natin yung data na yan. Kasi if we're not able to load it, then hindi natin we cannot do some descriptive statistics. Okay, so waiting for the others guys to. Okay, lagi po dapat i-code yung library every markdown file. Okay, thank you so much, Alistair, for this question. Alistair, pakishare yung, this is a very important question. Thank you. Alistair, pakishare yung question to everyone, please. Copy mo na lang and then share it with everyone. Alistair?
Sir, na-send ko na po.
To everyone ba?
Yes po, sir.
Sorry, hindi ko nakita. Thank you. All right, guys, very important question, Alistair. Dapat bang i-code yung library every markdown file if may gagamitin specific packages? Yes, that's correct, no? Now, again, if you're going to install a certain package, you used to install that package's function. And then you install it only once. Pero every time you open an R markdown file or an R file, right? R lang yan. And you're going for using R Studio, tapos kahit mag-R ka lang, R script or R markdown or R notebook, and if you're going to make use of ggplot2, guys, ggplot2, no? Kailangan ila-library siya. Kasi kahit na naka-install na yan, hindi siya automatically na-access. Kunwari, nag-open ka ng yung R markdown notebook, yung R markdown document. Tapos gagamitin mo yung function ng dplyr. Hindi mo siya library. Tapos kunyari, ginamit mo yung select function. Mag-error yan. Sabihin, hindi niya ma-recognize yung select. Kasi yung select guys, dplyr yan. Tapos pag ginamit mo siya without the without loading the package. So mag-error siya. Okay? So, thank you, Alistair, for that question. Did I answer your question?
Yes po, sir.
Okay, thank you. So which means, guys, na importante sa atin na alam natin, in fact, it's good to have a listing of the codes, no, of the packages. Kahit yung summary lang, ano ba yung ginagawa nun? Para later on, guys, ako ang suggestion ko, meron kayong kunyari isang notebook or isang list or isang Excel sheet, andun yung pangalan ng package, and then andun yung pinaka main description, ano yung functionality. Okay? Para if you might forget a certain package, tapos dun yung titingnan, no? Ano ba yung package dito na magbibigay sa atin ng ganitong output, then you can refer to that. Okay, that's a good practice. All right, so let's go back, guys. So ito na. What do you notice, guys? Sa data natin, di ba ito data, ito values? Di ba sa data, ang linalagay dyan, mga list at saka mga data frames? Sa values, ang linalagay, mga vectors. So you can now see that available na dito yung wage data set. 526 observations of 8 variables. In fact, kung tingnan natin yan, di ba? Ayan, no? Education, experience, tenure, race, etc. Okay, so bago kayo mag-multiple linear regression, may two things na dapat tinitingnan. Number one, do a descriptive statistic analysis. So for example, yung next project natin, multiple regression. So hindi pa pwedeng mag-regression kagad. Dapat muna, in fact, dapat isa pang ipapasok yung data visualization. I-plot nyo muna yung data nyo. Kasi di ba yung assumption number 1 natin kanina, sabi, linearity, no multicollinearity. Paano makikita yung multicollinearity? Well, statistically, you can compute, get the correlation of the variables. Pero, in addition to that, pwede nyo i-plot. Pwede tayo mag-plot ng scatter plot ng dalawang variables. Kunyari, variable 1, variable 2, these are independent variables. And if you see that they're so strongly correlated, may clue ka na malamang isa dyan matatanggal. Kasi may multicollinearity. Na-apektuhan yung data natin pag na-apektuhan yung model natin pag may multicollinearity. Okay, so we will need, guys, to do first some descriptive statistics. Examine muna natin data natin. And one way to go about it is to use the structure. No? Structure. Let's take a look at the structure of wage. Tignan natin. Okay. Diba sasabihin dito na si si wage, it's a data frame. No? Okay, it's a data frame. It's a table siya, data frame siya. Okay. We studied what a data frame last time. Okay, diba? It's an example of a structure na ito yung ginagamit natin pag nag-analysis tayo ng data analysis tayo. And what are the inclusions in this data? Anong sabi dito? Okay? So education daw, yung dollar dito, ibig sabihin yung variable. So wage, dollar education, this is coming from the wage data frame, and then the specific variable is education. Numeric siya, 526 observations, tas dinilista dito yung first few values. Experience, tenure, ganun din, race. No? Si race naman, character siya, white. Okay, now later on, guys, may gagawin tayo dito kay race. Kasi may magagawa dito tayo kay race, di ba? Ano ba yung race? Tingnan natin, ha? Si race, sige, tingnan natin yung tingnan mo natin itong ano. So, tingnan mo natin lahat, no? Okay, so are you wage? Okay, numeric. So, meron tayong mga character variables, meron tayong mga numeric variables dito sa data frame natin, no? Okay. All right. So, another way to examine the data is using the summary function. Summary galing to kay base R. So, wala tayong package na kailangan i-load. We use this in structure at summary. Run natin. Okay, so this one will give us, okay, it's the 6-number summary, di ba? yung minimum, which is your percentile 0, percentile 1, percentile 2. So this is your mean, percentile 3, and yung maximum natin. Okay? Alright. Si education, ang minimum niya 0, ang maximum 18, etc. So experience, ganun din. Tenure. Okay. Take a look at yung mga characters there. Siyempre, hindi naman makukompute yung mean, median, mode yan. So ang ginagawa niyan, bibilangin lang yan. Ilan siya, tapos anong class. Okay, anong class siya. So character. Alright. And then lastly, yung number of dependents at saka yung hourly wage. Okay, so with these two functions, guys, kita natin na yung structure, it will give us the type of data structure it is. No? So dito data frame, tapos numeric, character. Okay, baka makalimutan ko question to, guys. Sa tingin nyo, guys, si race, si gender, at saka si civil status, it's better to convert it into what type of data instead of character. I discussed that with you last time. May gamit yan, guys, race, gender, civil status. So instead of just classifying it as a character, what's the best way to classify them? Anyone? Yes, I think I see an answer. Yes, thank you. Thank you, Justin. You're correct, no? Tama. Factor. Factor siya, guys. Kasi kailan natin ito convert into a factor? Kung we can use it as a classifier. Okay? Kunyari, kung ano lang yan, first name. Diba ang first name, character din yun. Pero no point in using that as a classifier unless ang inaaral mo about first names. No? So, pinag-aaralan mo, you're conducting a study about attitudes of people with the first name Bob or Mabel or Matthew, etc. So kung gano'n, then hindi pwede gawin siya factor. Pero usually hindi, guys, depende sa study. Pero may mga, kunyari, address, character yun. So, bakit mo siyang gagawin? Bakit mo siya gagawin factor? Okay? Pero yung race, guys, yung race kasi yung white, tsaka non-white data, gender, female, male, civil status, single, married. Okay? So these are character variables that they can be used as factors. Kasi sa study natin, pwede natin, for example, dito kasi ang pag-aaralan natin yung hourly wage. Okay? Is there a difference between the hourly wage based on education, experience, tenure, between male and female? Okay, magagawa lang natin yan, guys, kung factors yung mga gender natin. If we're trying to see the distinction between the effect of independent variables on a specific dependent variable, kung may distinction ba, kung may difference, if the character variables are treated as factors. No? So, keep that in mind kasi gagawin natin yan. Okay, so let's move on. Okay, how about this descriptive statistics? Oh, a lot, guys. Ang dami natin pwedeng magamit, no? Okay, so first, sige, tingnan natin ha. Sa site package, meron tayong describe. Okay, so ito, makikita natin yung function na to. The site package has this describe function. And then, so, ano natin page. Okay, so let's see what happens here. This can give us descriptive statistics. Yan. Yan. So it gives us ito yung mga variables natin. Binibigay sa atin yung number. Okay, yung n. Kung ilan sila. Ibig sabihin, walang missing kasi pare-pareho silang 526. Aside from that, andyan yung mean, standard deviation, mean absolute deviation, mean, minimum, maximum, etc. No? Range, skewness, kurtosis, and standard error. Now, it's important for you guys, since hindi na tayo stat 1, kailangan medyo i-review nyo guys yung mga ibig sabihin nito kasi lalabas yan sa paper nyo. No? Yung skewness at yung kurtosis, it's important guys that you know them. Kindly review guys kung ano ibig sabihin niya. And for example, if education has a skewness of 0.8, negative 0.6, ito ano ibig sabihin? Okay? Si number of dependents, 1.16. What does that mean? Kung yun ang skewness niya, kung yun ang kurtosis niya, at saka yun ang standard error niya. Yung range, madali lang kasi minimum minus maximum minus minimum value lang yan. Okay, like this one. 6 minus 0, maximum minus minimum. So that will be the range for number of dependents, 6. Okay, but the rest, guys, please review. Okay, minimum, maximum, mean, standard deviation. Lalo na itong skew at saka kurtosis, pakireview siya. Okay, so let's add another one, guys. Let's use, si H-miss din meron. H-miss, may describe din siya. Okay, so magkakaproblema, guys, kung hindi natin in-identify. Kunyari, parehong naka-load si site at saka si H-miss. Okay, and then we're going to make use of the function describe. Magkakaroon ng error yan kasi hindi alam ni R kung kanino gagamitin. Okay, that's why sometimes it's helpful to know where that, to know the functions. No? Ito, si H-miss, may gusto akong i-generate na ibang klaseng descriptive statistics. No? It's coming from the H-miss package. And then it's also using the describe function. Magkaiba nga lang siya kasi ito sa site package. Ito naman kay H-miss. Let's run this. Okay. So you can see here that iba yung generate na describe output ni wage. No? Right. So yan, 8 variables, 526 observations. So ini-isa-isa niya. No? So si education, may missing ba siya? Wala naman. No? Distinct, 18 distinct values for education. So ano ibig sabihin ng 18? Kasi lahat 526. So ibig sabihin yung iba pare-pareho. No? Pare-pareho. Kunyari 10, siguro may mga 10 na pare-pareho. Kaya nga sabi niya 18 distinct values lang. And then my average, my I forgot what's this means. Yung median yata to or mode. Just check guys kung yung GMD. No? And then this is the 5th percentile. Okay? This is the 10th percentile. This is the 25th percentile or quartile 1, quartile 2, quartile 3. Okay, and then percentile 90, percentile 95. Okay, and lowest values niya 0, 2, 3, 4, 5. Yung 5 lowest values education and 5 highest values 14, 15, 16, 17, 18 pala. Okay, so may frequency dito, no? 0 value 0, 9, tapos 10, 18. So ilan daw guys? May automatic na cross tabulation dito, no? Ilan yung 0 years? Dalawa. Okay. Si 8 years of education, 22 yung respondents. Pinakamalaki yata si 12, no? 12 years of education, si 198 respondents. They had 12 years of education. Okay, so ganun din yon sa bawat variable, no? Ina-explain ni H-miss, no? Okay, so experience, so tenure. Pagdating dito sa dito sa character variable si race, no? 526 missing 0, dalawang distinct, non-white at saka sa white. So mas maraming si white 472. And then 89% siya. So dito guys, cross tabulation makukuha ng value dun sa H-miss na describe. And then gender ganun din, ilan yung female dito almost balance siya, ilan yung male. Civil status, mas maraming married kaysa married. Okay, so pag mga character variables guys, of course hindi naman kasi pwedeng compute yung mean, yung average, yung standard deviation, di ba? Pang lang yan, pang numerical variables. Okay, so that's another example, guys, coming from H-miss. Okay, another one. Ano pa ang pwedeng natin? So si scheme R, no? Di ba? Si scheme R, meron din yan, scheme R. Okay. You can use the scheme function in wage. Okay, this will also generate some descriptive statistics. Okay, so scheme R. Name, wage, rows, columns. Ilan yung character na na columns? 3. Ilan numeric? 5. May naka-group ba? Wala. Okay, so here we can see yung unang-una, ang pinapakita muna, okay, yung character muna na variables, yung race, gender, civil status. So si scheme, sineseparate niya, no? Yung mga character variables at saka yung mga numeric variables. Si character variables, okay, race, missing, wala, complete trait, okay, 100% complete, minimum, maximum, 5, 4, 6, I'm not sure about this. Empty, unique, dalawa. Okay, so may mga nuances siya, no? I'm not sure about, kalimutan ko na ano yung 5, 4, 6 dito sa race. Minimum, maximum. Okay, we'll have to check that out. No? Empty is missing din to, eh? Okay, so also for the rest, no, ganun din siya. And then for numeric naman, isa hindi niya, no? And then meron pa siyang ano dito, may konting histogram siya. Okay, histogram ng numeric variable natin. Okay, education, kikita natin ito, skewed to the left to, no? Laki ng concentration ng data natin sa kaliwa. Pati itong ano, si variable number 3, si tenure, 4 and 5. Alright, so and then lastly guys, maglagay tayo dito ng, di ba yung paste text, no? Kasi 4 yung ilan natin, paste text package. And then we can use the stat.describe. And then wage. This will give us also some summary statistics. Okay. Yan. Ito yung mga variables natin written along the columns. Okay, civil status, number of dependents, hourly wage. And then here are the critical measures. Number of values. Ilan daw yung null. NA, walang NA. Maximum, etc. So these are your statistical measures, no? Mean, standard error of the mean, confidence interval, coefficient of variation, etc. Okay, so we can generate several descriptive statistics required sa paper niyan, guys. Okay, any questions, guys? There are others. I will leave that to you to explore, no? Okay. Okay, clear ba so far, guys? Ang bilis ng oras, 3 minutes na. Okay, sige. Plot natin to. Now, will this work, guys? Yung plot, this is coming from the base R, di ba? Plot, sa x-axis si education, sa y-axis si hourly wage. So gusto natin ma-plot yung isang quantitative variable, education, na nasa x-axis, si hourly wage, yung sa y-axis. Okay, kasi guys, remember, ang gagawin natin dito, we would like to predict hourly wage. Si hourly wage yung variable of interest natin. Siya yung dependent variable natin. So when we plot them, guys, ang ilalagay natin sa y, yung dependent variable natin. So si x yung independent variable natin. Okay, did it run, guys? Bilis ang oras. Did it run? Yes or no? Okay, I hope I see several answers. Did it run? Let's see. Okay, thank you. No, hindi nga, guys, hindi nga. Bakit kaya? Bakit siya hindi nag-run? Kasi hindi na nare-recognize ni R yung education. Wala naman siya dito sa values, di ba? May hourly wage ba? Wala. So hindi siya mag-run kasi hindi naman niya nare-recognize tong object na to. Okay, ang nare-recognize niya yung wage. So how do we plot this? Well, we have to define, guys, na sa plot natin, dapat ito wage alert. So we're telling R that this is coming from wage, the wage variable. Ito naman wage, hourly wage. Okay, this is one way. This is one way. So, i-plot ko nga, guys. And this is the title, scatter plot of education and hourly wage. Nag-plot na siya. Nag-plot na siya, guys. Na-recognize na kasi ni R na si education galing yan kay data frame of wage. Okay? So you can see here na okay, yung medyo medyo hindi kita, hindi apparent yung yung relationship nila, parang scattered din, walang apparent na linear, so we will see, guys, when we do the regression kung si education ba is a good predictor. Okay, so what we're going to do, guys, as your assignment is try to plot the others, no? Try to plot the others. Pwede ba natin makuha yung correlation? Let's see, no? Correlation for correlation ni wage, wage education at saka wage, hourly wage. Yan. Will that work? Okay, it's 40.4. No? So medyo may weak na medium to medyo weak na correlation between education and hourly wage. Okay, so let me stop recording now. It's already time, guys.